In this problem, we need to find the equivalent stiffness of the system shown in figure. So the system is something like this. There is a beam which is fixed on one end, and on the other end there are two springs attached to the beam. One is at the top and one is at the bottom. The top spring is again connected to a rigid surface. The bottom spring is connected to a mass and then again connected to another spring. So this is the third spring which is connected to a rigid surface. So this is the problem. The beam is about 2.5 meters in length. The material properties are given, that is E is the modulus of elasticity, which is given as 210 into 10 to the power 9 Newton per meter square. I is the moment of inertia of the beam, which is given as 1.5 into 10 to the power minus 5 meter to the power 4. The spring stiffness is also given. The first spring stiffness is given as 5 into 10 to the power 5 newtons per meter. Let's call this as K1. Then the second spring stiffness is given as 2 into 10 to the power 5 Newton per meter. Let's call this as K2. Third spring stiffness is 3 into 10 to the power 5 newtons per meter. Let's call it as K3. Now we want to find the equivalent stiffness of the entire system. K equivalent is what we want to find in this problem. So if you look at this problem, you will see that the mass, that is M, is given, and so this will have a independent degree of freedom. A force shall be applied on the mass and it will have an independent degree of freedom. So let's consider if we apply a force on this mass, what will happen is the system of springs before this mass and the system of springs after this mass, they will have the same deflection. So if you look at this problem, you will see that the deflections, on the top of the mass, let's call it as delta 1, and the deflection at the bottom, delta 2, these two are same. Okay, so what that means is that K1, K2 and Kb, that is the stiffness of the beam, is having the same deflection as K3. Okay, so these are in parallel. These are in parallel combination. Okay, now once that is resolved, what we need to do is we need to understand the system that is above the mass. Okay, so if you look at that, what you have is K1, K2 and Kb. Now in this case, the K2 stiffness stretches and bends the beam. Okay, once you apply the force, what's going to happen is the K2 will completely stretch. So if you apply a force something like this, the K2 will completely stretch. Okay, after that it will bend the beam. Okay, so What that means is that K2 is basically um, in series with KB and K1. Okay, so KB and K1 are in parallel, and K2 is in series with KB and K1. Okay, so let's write this down. K1 and KB are in parallel, and K2 is in series with K1 and KB. So let's write down the equations again. What you will see is K equivalent is equals to 1 over 6 point. So what we need to do now is to find the stiffness of the beam. Okay, so KB is equals to 3EI over L cube. This is fixed and free at the other end. Okay, fixed at one end, free at the other end. Deflection you can easily find. So that's how you can find the stiffness. E is known to you, I is known to you, length is known to you. So this will work out to be 6.05 into 10 to the power 5 newtons per meter. Okay. Once you know what is KB and you already have the values of K1, K2, K3, now you can find the equivalent stiffness. So let's first add up K1 and KB. Okay, so K1B is the equivalent stiffness of K1 and KB. You know that K1 and KB are in parallel, so what you have is K1 plus KB. So this will be equals to 6.05 into 10 to the power 5 plus 5 into 10 to the power 5. So that works out to be 11.05 into 10 to the power 5 newtons per meter. Okay, now that's K1B. Now in order to find the equivalent stiffness of K1B and K2, those will be in series. So K1B2 you can find by reciprocal method. Okay, so 1 over K1B2 is equals to 1 over 11.05 into 10 to the power 5 plus 1 over K2. So K2 is 2 into 10 to the power 5. So this is K2. So you can easily find K1B2. Now similarly you need to find the equivalent of the system of springs below the mass. So that's going to be K3. K3 value is known. So K equivalent then is equals to K1B2 plus K3. So K3 is also equals to 3 into 10 to the power 5. So this total will come out to be 4.69 into 10 to the power 5 Newton per meter, and this is the final answer. Thank you.